For my project, I decided to go with periodic table and trends. A little background information. In 1789, Antoine Lavoisier organized the elements by their properties. Johann Wolfgang Daubrunner showed that elements could be arranged by their atomic weight, and not until the early 20th century it was discovered that the elements were actually determined by their atomic number. The periodic table was invented by a Russian chemist named Dmitry Mendeleev in 1869. The purpose of the periodic table is to help organize and classify the chemical elements discovered throughout the past couple hundred years by, like I said before, their atomic number and similar chemical properties. Now, normally the periodic table is not in a layout like I am showing right now. This is just to help better understand the different periodic table trends and groupings and different color coordinations. Now, as you can see here in the far left, I have labeled the difference between a period and a group. So the vertical columns are considered periods, and the horizontal columns all the way down are considered groups. If you look to the far right of this table, we would begin with the alkali metals in column 1 and the alkaline earth metals in column 2. You can also see here the period charges of +1 and +2 up at the top. Next we have the rare earth metals in green, followed by the transition metals in blue. Next is our metalloids outlined in red, as well as the halogens outlined in blue, and our metalloid and the noble gases outlined in purple. At the bottom left is a key with the color coordination distinctions that make it easy to follow when trying to find them yourself. You can see here that there is a distinction between the metals and non-metals using arrows to show where they begin and where they end. Use right here and up the top. Just like the alkaline metals, these two have charges. Up at the top you can see that they continue on at +3, ±4, and go back down starting at -3, -2, -1, and ending with 0 at the noble gases. You might also notice that each color group is accompanied by a letter. The letter's purpose is to separate elements into 4 groups of atomic orbitals. This aids in the electron configuration process. Continuing on about this periodic table layout is more fun organization. Up here in the top left is a key, if you wish, with the different trends on the periodic table. At the top is the name of what it is, and below are the arrows showing the patterns and how they go, and whichever way the arrow is pointing is where it is getting stronger. I've also included a definition about each one. To start, we have electronegativity, which is a property that measures the tendency of an atom to attract electrons to form a bond. And you can see here that up on the far left is going stronger, and right all the way at the top is getting stronger. Next is ionization energy, which is the minimum amount of energy required to remove an electron from a neutral atom outermost electron shell in the gaseous phase. And you can see that going up on the left is getting stronger, and going right on the top, just like electronegativity. Next is the melting point, which is the temperature at which a substance changes state from solid to liquid at atmospheric pressure. Next is atomic radius, a term describing the distance between an atom's nucleus and its outermost electron shell. And lastly is metal reactivity, the ability of a molecule or atom to undergo a chemical reaction followed by a release in energy. And that's everything about the periodic table and trends.